All right, let's have this chart, please. Definition, please. This can be defined. Hold on. This is also called volume flow rate. This is also called volume flow rate. Right, please. Right. This is also called volume flow rate. Are we there? This is also called volume flow rate. Volume flow rate. Volume flow rate. Are we there?
Yes.
It can be defined as the rate. It can be defined as the rate. It can be defined as the rate at which a fluid, are you there, comes out in a pipe per second. At which a fluid comes out in a pipe per second. A fluid comes out in a pipe per what there? Per second. Full stop. It is represented by Q. It is represented by Q. It is represented by Q. Are we there? Mathematically, discharge is equal to what there? Volume over time. Very important. That discharge is what there? Volume over what there? Over time. Are we there? Let's get SI in place. Look up. Volume is in what there? Meter cube. Abi? But time is in what? Second. So I'm saying that the SI unit for this time is what? Meter cube per. Please, this man is very important. Meter cube per what? Seconds. Are we there? Yes. Copy down, please. Copy down. Are we here? Are we here? Yes. So I'm saying that now, in essence, if I'm to write this one in abbreviation sense, this time is what? QRB equal to what? Volume is what? V over what? Over T. In terms of abbreviation, I have my answer. My formula for this as what? As this be aside discharge being equal to V over T, they see other expression for discharge. Look up. At this point now, other expression for discharge. Look up. Look up. Oh. We know that discharge Q is what? V over what? Over T. Please. In science, capital T represents temperature. Small t is what? Time. Please. Very important. So for me, look up. If I pick out volume, for instance, pick out volume. What's volume? Length times breadth times height. Abi? Now, usually, I'm taking them in terms of their SI units. Length is measured in what? In meters. Breadth in what? Meters. Height in what? In meters. Abi? I can write this as saying meter squared times meter. See correct? Abi? Yeah. Meter times meter is meter squared. Abi? And meter. See correct? But what? Different expression. So I'm saying that V now is what? Meter squared times what? Meter. Abi? Keep this man pending. Are we there? Focus on T. Time. That's small t. What's the unit there? Seconds. Abi? So in this thing now, discharge Q equal to what? What's V? M squared times what? M over what? What time? Seconds. Are we there? Break this down. I can see that Q is equal to what? M squared times what? M over T. See correct? Sorry, over S per se. The same language. M squared times M will give what there? M cube. Abi? Yes. This S is TX now. But I'm just trying to make the different expression. See correct? Now for me now, look up. Q is equal to, in science, there is one thing that should represent M squared. Either centimeter square or meter square. What's that parameter? Area. Meter cube is what? Volume now. Yes. Meter square is what? Area. So our area, Abi, times in science, there's one thing that represents meter per second. That's what? Velocity. So what's the answer there? Velocity. So I'm saying that this charge now is what? Area times what? This was Oman give in class. This is how to derive it, please. This derivation. Aside V over T, I still have what? AV. Very important, please. This is how it's derived. Copy down, please. Copy down. Let's proceed. Let's proceed, please. All right. We'll look at one past question then to solve this. Then we'll hope, please. Move other stuff. So this has two expression V over T or area times what? Velocity, please. That's it, please. Are you true? Yeah. Let's do past question, please. Number one. Let's do past question. Let's finish up. A pipe AB capital A and B. Yeah. I don't use. Okay. A pipe AB capital A and B. A pipe AB branches into two pipes C and D. A pipe A capital A and B branches into two pipes C and D. C and D. Are you together? As shown in the figure below. As shown in the figure below. Do not draw this here to hold on. I said a pipe AB branches into what there? Pipe what? C and D. Are we there? As shown in the figure what? Below. Full stop. The pipe has diameter of is 0.45 meter at capital A at A. The pipe has diameter of 0.45 meter at A. Are you together? Comma is 0.3 meter at B. 0.3 meter at what? At B. Comma 0.2 meter at C. 0.2 meter at C. Are you there? Yes. And 0.15 meter at D. And 0.15 meter at D. Full stop. Are you there? It says find the discharge at A. Capital A, please. Find the discharge at what? At A, comma. If the velocity of water at what? A, Abi? At A is 2 meters per second. I said find discharge at A, comma. If the velocity of water at A is 2 meters per second. Are we there? Yes. Comma. Also find the velocity at B and C. Yeah. B and D. Sorry, please. Also find velocity at what? At B and D. Comma. After that, yeah. I said if the velocity of water at A is 2 meters per second, and I said also find the velocity at B and D. Are we there? Yes. If the velocity at C, is what? 4 meters per second. Yes. If velocity at C is what? 4 meters per second. Yes. Are we? Yes. Is that all? Check up again. Yeah. We are all good, are we? So first, your first task in science is to what? List out parameters, are we? Yes. But hold on. Let me explain something here. Look at pipe A and B. They are in the same linear concept, are we? Yes. But look at C and D. They have a branch. Yes. In a real life sense, if I put water into this thing now, the way water will flow at A and B will be the same thing. Exactly. Because they are linear. But the way water will enter C and D will be different. Yes. For C, it will be slower. It will not move faster. True, because it's going up, Abi. For D, it will move faster because it's coming downwards. So in essence, so I'm saying that the rate at which water will enter pipe A and B will be the same, Abi, but different in what? C and D. It means that I'll be having my expression as QA equal to what? QB, because they have the same flow rate, but equal to what? QC plus what? QD. This one are not the same. They are different. I maybe plus in the middle. So note that if I was having a pipe this way, I was having A, B, C, D. There will be of what? Of the same charge, of the same what? Q. Are you there? But mind you, C and D are branching in this sense. The rate will be different. So I mean what? QC plus what? QD. Not this expression. Are you there?
Yes.
Hold on with this. Let's write out givens, please. Okay, give me the question, please. It says what?
Our G and
I'm coming, please. It says the pipe has diameter of what? 0.45 at A or B. So diameter at section A. Sorry. Diameter at A is what? Is 0.45 meter. At what? At B is what? Is 0.3 meter. At C is what? Is 0.2 meters. At D is what now? 0.15 meter. Look at the way I'm placing that parameter. Start the diameter. D diameter. So DA, DB, this and what? DD. Are we there? We're going to diameter B. It now says find what? This is at A, B. Find what? Q what? A is unknown. That this is at A. Are we there?
Yes.
It now says again DA, B. B and C. B is 0. Okay. B is 0.3. Yes, 0.3. C is 0.2. And D is what? 0.15. Yeah. Abi, let's proceed, please. It says find distance at A, Abi. That's QA. This card is Q now.
Yes.
QA. What next? If velocity of water at A is what? So VA, Abi. Velocity of water at A is what? 2 meter per what? Per second. What next there? Also find what? Velocity at B and D. That's what? V what? VB is unknown. VD is what? Unknown. Is that all?
Yeah.
So that's Abi.
Yeah.
BC Abi is what? 4 meter per second. But that's all, please. Let's solve this, please. Let's solve this problem. My very first task is that observe that so far I'm looking for this charge. When it comes to this charge purely, I need V and A. But I'm not given A area here at all. I'm given what the diameter. I'll not convert diameter to what? Area text. So my first task is that calculating for what? Area. Are we there?
Yes.
Now I have several sections here. A, B, C, and D. Abi. Start for section A. For section A, look up. What is my area? That becomes area at section A. Are we there?
Yes.
Is what? Pi what? D square over what? Over 4. To convert diameter to area, the formula is pi d square over 4. But I was explain in terms of what? In terms of A. So that this what is to be DA instead. Because I'm at point A. So area at section A now is what? What's pi? 3.142 times diameter at section A is what?
0.45.
Is 0.45. But what? There's a square there, Abi. Square, Abi. Over what? Over 4. Please give me total value, please. Area at section A is what, please? Everything total, please. Area at C is what? What are there? Is 0.988, Abi? Are you correct? Are you sure?
0.159.
0. What? 1.5 what? 9, Abi? In what? Meter square. Because area is square. Area is square. We said calculating for area should be square. This side is meter cube, not this side here. So what? This is my first area, Abi. What next there? Section A is off. For what? For section B, what's my area? Because area at B is what? That same thing, pi d square over what? But on what in B, Abi? So this becomes what? What's pi? 3.142. What's d at B? 0.3. What there? All squared over what? Over 4. Give me area at section B. What's my answer, please?
0.070.
Is 0.0 what? 7 what? 0, Abi? In what? Meter squared. 1 meter squared area.
Yes.
Abi? That's section B. For what? Section what? C. What's my area? Area section C is what? Pi d squared, but then of C, Abi? Over what? 4. What's pi? 3.142. What's DC? 0.2. Or what there? Over what? Give me AC, please. 0.031, Abi? 1 what? Meter what there? Square, Abi? Here's the thing. If you give me a wrong answer, there was a day whereby I was chatting online and I saw a comment from YouTube. With all the respect, sir, the answer is not this, is this. I was like, it's not that in class. I'll tell you, give me an answer. But if I give me a put here, you give me a wrong answer. That's why they'll be missing with respect, sir. So anything I give you here, make it correct. Let's put this. As well as AC, Abi, let's get what? AD, Abi. So okay, copy down, please. Copy down. Okay. Which one? Which one? From here, Abi? Or from where? This pi you're seeing. Pi is a constant. Does not change anywhere you go in life. This stuff is pi. It's constant. 3.42. Does not change. That's why we have it as this value here. And now, if you are faster, but this is way, that's where you earn more mark. You should step by step.
Okay.
All right, should proceed.
Yeah.
Huh?
Yes,
Let's focus now, please. For what there? For section what? D, Abi?
Yes.
D. All I have there, area section D is what? Pi d square over what? But this is what? In terms of D. What's pi? 3.142 constant.
Yes.
Times, what's your D at D? So 0.15, Abi? Or what there? Over what? Over 4. So what's my area at D, please?
0.0176.
0.017 what there? In what? Meter square. I'm done. Convert it to what? Area. What are we looking for? Gongo. What is the first question there? Find what? Q at A. Abi? Alright. Calculating for QA. Let's get this done, please. Let's start with this. All together?
Yes, sir.
Can I click this part?
Yeah, sure.
Huh?
Yes.
Alright. There. First, what are we going for first? QA, Abi? Now look up. Neutrally, Q itself is what? AV, Abi?
Yes.
But A, in terms of A, because what? QA, AA and what? VA. In terms of A, QA, VA and what? And what? VA. In terms of A. Abi? So I'm saying that QA now I'm looking for is what? Area at section A is what? Check a book. Is that what?
0.159.
Abi? Is 0.159, Abi? All over, sorry, times what's VA? Huh? They gave us, Abi? They gave us VA, Abi? So, Abi, what's QA, please?
0.318.
318 in what? Meter cube per second. Why? Discharge. I'm done.
For the QA.
Yes, Q is done. Q is done. Q is done. Is it recording? No shake the table so that it's not be blinking. Alright. Should proceed?
Yes, sir.
Let's what? What next there? Find what? Q and what?
You're finding the velocity at
VB Abi?
Yes.
Alright. Calculating for what? For VB. I'm taking step by step, small, so you understand. Look up, hold on, look up. It was QA, Abi,
yes.
In terms of A, right?
Yes.
Here be what? VB, Abi. It become what? QB is what? AB times what? VB. In terms of B, Abi. Yes. So I'm looking for this man here, Abi. I need to know AB and what? QB. If I know AB, yes, that's B. Yes. If I know VB, no. I'm looking for it, Abi. Yes. If I know QB, not yet, Abi. But we know that we said earlier that before now that we said QA equal to what? QB. Because the properties A and B are similar. Yes. So what the answer I use for QA is what I use for what? QB. What's that answer? 0.318. That's the concept. Now hold on. What's QB now? What's QB? 0.318, Abi. What area at B? Yeah. This man. 0.070, Abi. Yes. Times what? VB. You're looking for. For me, 0.318 equal to what? It's 0.070 VB. Maths. Apply maths here. Get it well, do. By what? 0.070 by what? 0.707. Abi? 0.070, Abi? This cancel what? Let's get VB, please. Okay. Hold on, I'm coming. Let's get area. Sorry. Volume at what? Velocity. At B, Abi. So VB now is what? Divide this what I have. 4.5 in what? Meter per second. Just 4.5. You know it's volume A. Velocity. It's not too long. Just a specific value like O number and just to decimal place. So I have my answer as what? 4.5 as my volume at what? At B. Is done. Is done. Is done. What else again? What else again? Huh? VD Abi and what? That's all Abi. VD Abi. Yes. Now look up. Here's the thing. If I'm to get VD, I need to know what? QD, AD, and what? That VD itself. Yes. Look up. Let me do before I do that VD. Let me show something. I want to do some step. But I want to show why I will go to that step before I get VD. But to get VD, we need to look for what? QD equal to what? AD times what? VD, Abi. I need to know AD. Is it known? Yes. Area at D, Abi. Did I know QD? No. Before I can find QD, I need to know what QC. You know why? Before you pass through that pipe, you pass through A, before B, before C, before D. You can't fly C and go D. You should know that value for D before you go to C. For C before you go to what? D. Now my task now is that I know I'm looking for VD, Abi, but I'll branch to some parts to get what? VD. What's the part? Here's the thing. Exactly. For me, I'll do what? Calculating for what? QC first. What's QC? That's what? AC times what? VC. But they give us this one. They give us QC, VC. Yes. Check. Yes. Abi? That's what they give us. They want us to pass through it. That's what they give us. Now, QC now is what? What's AC? Check. 0.031. You can see why it's important to find your area first. Now just picking it there. But if I don't find it, you're stressing yourself. So if you now come and start saying area C is pi d square, waste your time. Don't do them separately. Then just pick an answer. So what do you say QC is what? 0. What? 0.1 Fabi. What AC? Area C. 0. What? 31 Abi. times what your VC? 4 Abi is given the question, Abi.
Yes.
Let's get QC, please. What's QC? 124 in what? Meter cube per Y discharge Q. I've gotten QC, Abi. Let's get that VD, Abi. Let's get VD now. Okay. Yes, that's diameter. That was before now. What we did initially, all those DDD to area that we did initially. Some people don't do that. BC is velocity, not area. B is velocity. Yes, that's the concept. Right? Now look up. Should we proceed? Now hold on. Before I can get VD, look up VD. We know that. Look up from here. We know that what? QA equal to what? QB equal to what? QC plus what? QD. I can get VD inside QD. True? I can get VD inside what? QD. Abi? Now hold on. QA and QB are the same, Abi? What's the value? 0.318, Abi? What's QC, please? What's QC? 0.124. I can get QD now. Make you the subject and get what? QD from here. I'll not lose that QD. Equal to, we said to get VD. Need to know QD, Abi. Now we said it. I gave it for now. So QA and QB is this value, Abi. Now, but QC now is found as this, Abi. You cannot get QD. Inside QD, I'll get what? VD. How? QD is what? AD times what? VD. Yes, from here. If I know this one now, I cannot get what? VD. This one is constant. I know them already. That's how it works. So leave analysis for now, Abi. Let me quickly stop. I just want to show you something. Now I want to get VD, Abi. So here's the thing. Calculating for what? VD, Abi. Yes. What do we know? We said QA equal to what? QB is called. Should we proceed? Now we know that QA equal to what? QB, Abi, equal to what? QC plus what? QD, Abi. These two values what? 0.318, Abi. What's QC? 0.124, Abi, plus what? QD. Let's get QD. How? Take this man here. Yes. Because what the 0.318 minus what? 0.124. What of what? Please, what's QD? 0.1. Permit me. Can I please part? Yes. Huh? All right. So QD is what there? QD is what? 0. What? 19 what? 4 in what? Meter cube by what? Discharge, please. Discharge. Hold on. What are we looking for? VD. So I will express this in this way. QD is what? AD times what? VD. Abi, make with the subject. VD here is what? QD over what? AD. True or false? Yes. What's QD? Known already, Abi? Yes. 0.194 over what's AD? Check your book. 0.017. 0. What? 017. 17, Abi? 6, Abi? What's my answer, please? Yeah. Exactly. Approximately, Abi. Therefore, VC is what? 11 what? Meter per second. Why? Velocity. I'm done. That's all. That's all. That's all, please. Huh? Oh, sorry. It's VD, please. VD, please. That's how to solve this problem, please. That's all, please. I'm coming.